Lesson 71, Factoring Trinomials with Common Factors. And we're also going to solve systems of equations with subscripted variables. So in this case, remember that we always want the expression to have the terms in descending order. So we look at x3, x2, x1. So it's ready. Now, all of them have an x, so we're going to get that as our common factor, and we're going to divide. So x3 divided by x is x squared. 6x squared divided by x is 6x, and then 5x divided by x is 5. Once we have it like that, we are ready to factorize like we learned in a previous lesson. And in this case, what we need to do is find two numbers that multiply give me 5 and added give me 6. Now 5 is a prime number, so we only have one pair, 5 times 1. And so that's our answer. We just put plus 5 and plus 1. Now, our factorization includes the x, the common factor, so don't forget it. In this next example, I would recommend you stop the video and try to do it by yourself. Start by factoring the common factor. Okay, so what we have to do is find the common factor, which in this case is 4bx. That is the common factor for all three terms. When I divide, I get x squared minus x minus 20. And now we are ready to factorize the trinomial. So we put the two parentheses and the x here at the beginning. Now two numbers or two factors of negative 20 that added give me negative 1. Remember there's a 1 here, negative 1. So I'm going to do it here, negative 1 times 20, negative 2 times 10, negative 4 times 5, negative 5 times 4, negative 10 times 2, and negative 20 times 1. And again, if I do the additions of each one of these, I'm going to get here 19, 8, 1, negative 1, negative 8, and negative 19. So the pair we want is negative 5 and positive 4, because negative 5 times positive 4 is negative 20. And if we add it, negative 5 plus 4 is negative 1, which is what we want. Remember that your answer has to include the common factor. Let's look at this other one. Again, we check that it's in order, and it is because it's x3, x2, x1. And the common factor is negative 3x. When I divide each one of those, I'm going to get x squared plus, because negative 6 divided by negative 3 is plus 2x. And then minus 24. Now we are ready to factorize the trinomial. So we'll put the x and the x. And remember, we're looking for a pair that multiply, give me negative 24, and added, give me positive 6. So just since we're practicing these, I'll do it here really quick. And now we're looking for which one of these pairs, if we add them, gives us positive 2. And the answer is negative 4 and plus 6. So I'll put here plus 6 and minus 4. Remember, you want the number and the sign. So that's it. That's our answer. In the second part of the lesson, we're going to practice how to solve systems of equations with subscripted variables. Now, the subscripted variables are the same thing as x and y, but they represent something. So, for example, for n, we can say represents the number of nickels, or the number of nuns, or the number of notebooks, whatever that we can say that starts with n. And for nd, we can say is the number of dimes, or the number of dogs, or the number of diamonds. So it's just a different way of doing the equations to have very clear what each of the variables represent. Because if we're talking about, for example, nickels and dimes, it would be hard to remember if x represents the number of nickels or the number of dimes, and if y represents the number of nickels or the number of dimes. And that's why we use subscripted variables, just so that we remember clearly what we're working with. We solve it exactly the same as if we had x and y. So they're asking for elimination, so we're going to multiply here times negative 10. So let's rewrite these. The equation on the top is not going to change, and the one on the bottom I have negative 10 nn. If I multiply these two, negative 10 nd. If I multiply those two, and negative 160. Now we're ready to add. Remember, that's what we do in elimination. We add. And these two, 5 minus 10 is negative 5 nn. The positive and negative cancel. And if I add these two, is 125 minus 160 is negative 35. Now we're ready to divide. Negative 35 divided by negative 5 is 7. So the NN, whatever represents the number of nickels, is 7 nickels. The number of notebooks, 7 notebooks. Now remember that to find the other one, we go back to the original and we change the value that we just found in the equation. So in this case, we know that NN is 7, and so we put it in our equation here. Then we pass the 7 that is adding to subtract, which is 16 minus 7, and the answer is going to be 9. Now in this case, we don't write our answer as a point. We don't put 7,9 because we're not talking about a point. We're talking about something else, like nickels, like dimes, like diamonds, like dogs, like whatever the N and the D represent. So it's a very simple thing. We just have to get used to working with the NN and the ND or whatever subscriptive variable we're using, but it's the same process as for elimination and substitution. Let's look at this other example that has NN and NQ. So again, that can represent number of nickels and number of quarters, but the process is the same. We're gonna do, in this case, substitution, and they give it to us ready. They say NQ equals NN plus 2. So we're gonna change in the one on the top, the NQ for NN plus 2. Remember to use parentheses. So instead of NQ, I write NN plus 2, and then I have that equal to 290. Then we get rid of the parentheses by doing distributive property. So 25 times NN is 25 NN, and 25 times 2 is 50. 25 plus 5 is 30 NN, and then the 50 that is adding goes to subtract, so 290 minus 50 is 240. And then if we divide 240 divided by 30, the answer is 8. And now we go back to the original to find NQ. So all we have to do is add 8 plus 2, and that is NQ. NQ equals 10. And that is our answer. Very, very simple. So go do some practice, and if you have any questions, let me know in the comments, and I'll see you in the next video.